We're looking at problem 6 from the Graphing Rationals worksheet, and here we're asked to graph this rational function. And you're asked to go through the entire procedure, finding all the different asymptotes and intercepts and holes, if any, of the graph. And you should always start off by trying to find any holes, any points of discontinuity. You know you have a hole in the graph if there's a common factor of the numerator and the denominator. So the first step should really be to try to factor your rational function to see if it can be simplified. Here your numerator factors into x minus 3 times x plus 1. Here your denominator stays as x minus 2. There's no common factor, so there are no holes, no points of discontinuity. But that's always the first step, because remember, the holes take precedence over any asymptote or intercept that you might think you have in your graph. When you go about graphing rational functions, my advice is to graph it in a standard view and just look and see what the graph is showing you, and it could really push you in the right direction as far as finding the asymptotes and intercepts of your graph. Here's what this rational function looks like in the standard viewing window. At first glance, it appears that there's a vertical asymptote somewhere along the graph. Remember, you calculate your vertical asymptotes by setting your denominator equal to 0 and solving for x. So here our denominator is x minus 2. We'll set that equal to 0. And it looks like we get x is equal to positive 2. So our vertical asymptote is x is equal to 2. Notice this vertical dotted line appears to go through the x-axis at positive 2. Another way to check to see if you have your asymptote correct, if it turns out to be a whole number, is to go to your table of values and see what your calculator gives you at 2. And sure enough, when you do that, you see that when x is equal to 2, it tells you y is equal to error. So it's nice when your vertical asymptote turns out to be a nice whole number or an integer. The problem is you can't just go to the table because, number one, your asymptotes may not be a perfectly whole number, and number two, your calculator will also give you error messages if there are holes, if there are points of discontinuity in your graph. Next, I'm going to calculate the horizontal asymptote, and the way you do that is you compare the degree of the numerator and the degree of the denominator. In this case, the numerator's degree, the highest power of x, is 2. So here our n value is going to be 2. Here our denominator's degree is going to be 1. So this is the scenario when n is greater than d, so there is no horizontal asymptote. Remember, if n is less than d, then your horizontal asymptote would have been the x-axis. If n is equal to d, then you would set up the line y equals the lead coefficient of the numerator divided by the lead coefficient of the denominator. So here there's no horizontal asymptote, which makes sense when you look at the graph because it doesn't appear to be a horizontal line that kind of cuts through the graph that the graph avoids. However, this particular rational function has a slant asymptote. You know you have a slant asymptote if the degree of the numerator is 1 more than the degree of the denominator. And here, since n is 2 and d is 1, n is 1 more than d, so we're going to have a slant asymptote. And the way we calculate the equation for the slant asymptote is we do synthetic division. We're going to take our rational function and divide our denominator into the numerator using synthetic division. Here, since our denominator is x minus 2, I'm going to be putting a positive 2 on the outside. And on the inside, I'm going to have 1 for x squared, negative 2 for x, and then negative 3 for our constant. So we're going to do some synthetic division, and the equation you are left with is going to be the equation for the slant asymptote. And when we do this, here you get along the bottom of your synthetic division 1, 0, 3. So this is going to be the equation of our slant asymptote. Here, since our numerator was a degree 2, it was an x squared, our resulting equation is going to be one less degree, so it's going to be degree 1. This 1 is going to stand for x to the first, this 0 is going to stand for x to the 0, and here we're going to have a remainder of -3. So the equation we have left is y equals 1x to the first plus 0x to the 0 power. When you do synthetic division to calculate your slant asymptote, the remainder is not part of the equation. So here is our equation, y equals 1x to the first, so x, plus 0x to the 0, which is just 0. So here the equation y is equal to x is the equation for the slant asymptote. So here, the slant asymptote is going to take the place of the horizontal asymptote. Watch what happens when I graph the equation y is equal to x and compare it to our rational function. All I'm going to do is enter in a second equation, in this case the equation y is equal to x, and look and see what that does to our graph. Notice we have our rational function here graphed in blue, and notice as it goes to the left or to the right, it definitely avoids this particular red line. That's the line y is equal to x. So here we're going to have a slant asymptote at that equation, and I'll show you how we're going to go about graphing that in a moment. Next, we're going to go about calculating the x-intercepts, or the zeros, by using the second calculate in option 2 value on our calculator. So this particular rational function has zeros at -1, 0 and 3, 0. Remember, asymptotes are equations of lines. Vertical asymptotes, x equals. Slant and horizontal asymptotes, y equals. Intercepts are just coordinates of points. So here it has 2 zeros at -1, 0 and 3, 0. And to get my y-intercept, I'll just go to my table of values when x is equal to 0. So here our y-intercept turns out to be the point 0, 3/2. So now we did the entire background for this rational function, and now we're going to go about making our graph. When you have to graph rational functions, you have to include your sketch to have all the intercepts, so the x and y intercepts, the holes of the graph, if there are any, and any asymptotes. And the good thing is that a majority of these rational functions, the standard viewing window is going to be good enough. So here I'm going to use the standard view to make my graph. Here the intercepts, the x-intercepts are -1, 0 and 3, 0. Here the y-intercept was the point 0, 3/2. So I plot those as points. If there were any holes, I would indicate them by open circles, but here there are no holes in the graph. Here we have the vertical asymptotes, or vertical asymptote to be x is equal to 2. So I'm going to go just to the left of when x is equal to 3, that x-intercept, and draw my dotted line. The horizontal asymptote didn't exist. The slant asymptote is the line y is equal to x. We're always going to draw our asymptotes as dotted lines because the asymptotes are actually not really part of the graph. They just give the graph structure. They give the branches a direction. So here I have my intercepts. There are no holes. I drew my asymptotes. So here we're going to draw our rational function going through the x and y intercepts. So here's what this graph of the rational function should look like when you graph it.